All right, what's up, everybody? Before we get into what I really want to talk about today, quick little side fun fact. So we've talked about before making shapes bigger by a factor of 2, 3, whatever. They call it a growth ratio or a growth factor. For instance, if I have a rectangle, it's a 3 by 6 rectangle, and I want to make it 2 times bigger, I could easily do that by doing what to both of these sides. If I'm making it 2 times bigger, well, just multiplying the side lengths times 2, and that would make it 2 times bigger. So 3 times 2 is 6, and 6 times 2 is 12. So that would be how I could make that shape bigger. Now, I already know how to do this with side lengths, or lengths in general. If you're making something times bigger, you just multiply by that something. But I want to talk about areas today. So, what's the area of this rectangle? The area of this rectangle would just be 3 times 6. So the area of this rectangle is just straight up 18. The other one, on the other hand, the area of that is 6 times 12, which would be 72. And interestingly enough, what we're going to try to look for is what is the growth factor for the area. I already know what the growth factor is for the side lengths. It's just the side lengths times 2. But I don't think 18 times 2 is 72. So area doesn't seem to play by the same rule. So the question is 18 times what is 72, and how does that relate back to the growth factor? So let's do a few more problems and see if we can figure it out. So 1 times 3, that area is 3. If I made this shape 2 times bigger, multiplying both of these times 2, so this would become a 2 and this would become a 6, right? The area for this would be 2 times 6, which is 12. Now, again, 3 times 2 is not 12, so something else must be going on. And if you look between these two, I think this might be a little bit easier to see because the numbers are smaller. How many times bigger is this area than this area? If you guessed 4, then you're right. Let's see if that works too. 18 times 4, let's see here. Heck, that's 72. So that also is times 4. Let's just check to see, maybe areas are just like 4 times bigger. Let's see if this works. So I'm gonna get the area of just this triangle real quick, and then I'll see if it actually works. I'm gonna try to predict before I even make the shape 2 times bigger. So the area of this would be 13 times 12 divided by 2, because again, that's the formula of a triangle. So that would be 78 units squared. If this is still true like all the other ones, if I were to multiply 78 times 4, that would be the area of this new and improved triangle. Let's see if this indeed holds weight. So 78 times 4 is 312. Let's see if this makes sense. So if I make this shape 2 times bigger, aka multiplying these times 2, 13 times 2 is going to be 26, and 12 times 2 is going to be 24. Let's see if 26 times 24 divided by 2 is 312. So 26 times 24 is 624 divided by 2, that's 312. So what do you know? It works. The area is 4 times bigger. I guess the question is how do I know what the new area would be if I only know what the growth factor is? Meaning, how is this related back to this? Well, to learn a little bit more about that, let's try a different growth factor. This time, let's try, I don't know, say for example, 3 times or 4 times bigger, okay? So let's try this out. If I made this shape 3 times bigger, that would make each length, well, 3 times 3, that would make that 9, and 3 times 2, that would make that 6. The area of this shape would just be 3 times 2, which is 6. The area of this shape would be 9 times 6, which would be, what would that be? Oh my goodness, 54. Now, like last time, is it 4 times bigger? Well, 6 times 4 is 24. It ain't gonna be 54. So 6 times what is 54? And if you guess 9, that is absolutely correct. So this area is 9 times bigger than this area, okay? And then last but not least, let's try something that's 4 times bigger. So if I made this rectangle 4 times bigger, that would make this, what, 12, and then 4 times 2, that would make that 8. The area of this would again be 6. The area of the other one, 12 times 8, would be 96. take a second. What does anybody have any idea of what that times 6 would be? 96. How many times bigger? Because again, it's not 4, it's not 9, it's not any of those. So what might that be? And if you guessed 16, you are correct. So I guess the question then is the following. So if going back to this problem at the beginning, if I am making this shape 2 times bigger, the area is really 4 times bigger. If I'm making this shape 3 times bigger, the area is really 9 times bigger. If I'm making this shape 4 times bigger, the area is really 16 times bigger. So I guess the question is what are you doing? What can you do to this growth factor if I have the area and I want to find a new area? What is the trick? So for instance, I don't know anything about the lengths of this shape. I just know what the area is. It's 10 feet squared. I want to make this weird gobbledygook thing 5 times bigger. What would the area of the new shape be? And it's not going to just be 10 times 5. So what do you suppose it is? How many times bigger would I have to multiply 10 by? And the answer is 25. 10 times 25 is 250, so this area would be 250 feet squared. If you haven't figured it out yet, what's going on is that the growth factor is being squared, and that is the number of how many times bigger the area is getting. Okay, so that is pretty much the fancy trick that we are going to be writing down in our notes today. So here's what I would like you to write down. If I have an area and it's r times bigger, if I want to figure out that new area, I would take the original area, right? And I'm going to multiply it by not how many r times bigger it is, but r squared. And that is the big takeaway. Okay, so let's just apply this to one last example, and then we'll wrap up. If I have the area of a shape, I don't know, let's do 50. Okay, so I have this shape. It's a weird shape. It's 50 centimeters squared, and I want to make this, I don't know, 8 times bigger. Okay, what would the area of the new shape be? Well, I'm not going to do 50 times 8, but if I take this growth factor and I square it, that would give me 64. That would be what I would multiply the area by to get my new area. So 50 times 64, and that would give me 3,200 centimeters squared, and that would be the area of the new shape. That is 8 times bigger. So the takeaway again is that when you increase something so many times bigger, lengths are just multiplying by that growth factor, but area are multiplying by the growth factor squared. And again, there's a nice little symmetry here. Like, think about the notation for areas, right? It's units squared and the growth factor squared. So it's a nice way to remember that is how areas grow when you're making them certain times bigger. So if you look at your homework from the other day with the area of the polygon, I asked you to do one that was like really repetitive, and it was the area of a polygon whose radius was 1, and I kept kind of just upping the number of sides. So a couple quick, I guess, checks. So if the number of sides of the polygon is 5 with the radius of 1, the area of that polygon is going to be 2.37. If we upped it to 10 sides with a radius of 1, it would be 2.93. 20 sides, this is what you should have been getting, around 3.1. 50, about 3.13. 100, about 313. But if you round it, it'd be like 314. And I asked you, hey, that's very close to some really kind of like you must have heard of that kind of math number before. In fact, let me just drive it home just a little bit more. Say, for example, I did, 200 sides, or 500 sides, or heck, 10,000 sides. I think you're starting to get the point. The area of those shapes are almost perfectly getting, this number, pi. 3.14159, so on and so forth. So why is that? Well, that is because if you take a polygon and you keep increasing the number of sides until it has, like, I don't know, an infinite amount of sides, you'll notice that that shape is pretty much becoming a circle. So let's talk about circles real quick. I know you've heard this before, but hopefully this is going to start making a little bit more sense in terms of why the area formula for a circle is what it is. So first off, with the radius of 1, if we take what we know about triangles and polygons, we can pretty much approximate the ratio of pi. Okay, so that's where that pi part of the area formula of a circle comes from. Now, the next part of the area circle, where does that come from? Well, earlier in the video, I talked about growing areas by a certain factor of something, right? So for instance, we know now that the area of this circle is pi, right? And the length of that radius would be 1. So if I'm going to make this circle, for instance, a radius of 2, how many times bigger side length wise is this circle to this circle? And the answer is, well, it's 2 times bigger. Well, we said earlier in the video that areas don't grow like side lengths grow. They actually grow a little bit different. So question, the area of, for instance, this one isn't going to be 2 times bigger of this area. It's not going to be 2 pi. It's going to be 4 pi because it's going to be this squared, or the radius squared. So the area of this one is going to be 12.6. Similarly, if I compare these two circles, if this is 3 times bigger in terms of side length, the area of this one is going to be 9 times bigger than this. Again, 3 squared. So when we look at the area formula of a circle, hopefully this is starting to make a little bit more sense, that the pi part of it comes from, like, you know, the infinite amount of sides of a polygon transforming into a circle, that part. And then the second part of it comes from the fact that areas, when we make them X amount of times bigger, in this case, we're changing the radius from the original, like, 1 radius to, like, a different size radius, that we're squaring that growth factor to get that new area. So that's really where the area circle, or the formula for the area of a circle comes from. So for instance, 3 or 2 that we were doing earlier is really just pi times 2 squared, the 2 squared coming from the fact that you have to square the growth factor of 2 to figure out that new area. Or for instance, the radius of 3 is really just pi times 9, which again is you're squaring that growth factor to get that new area. So now you should know how to find the area of circle and why the area of a circle's formula is the way it is. Now you should be able to do the assignment today. So I hope you guys have a wonderful day. See you later.